Good morning, everyone. Thank you for joining us today. My name is Kevin Curry, and on behalf of the Mobility Development Group, I would like to welcome you to our webinar, Voice and SMS Support over LTE Multimode Devices, presented by Srini Balasubramanian. Before I introduce our speaker, I'd like to remind everyone to please submit your questions via the Q&A tab located in the right-hand portion of your screen. We will answer all questions at the end of the webinar, time permitting. If your question is not answered live, we will follow up with you via email. Now I'd like to introduce our speaker today, Srini Balasubramanian, Senior Director at Qualcomm. Srini has a BE in Electrical and Electronic Engineering and an MSc in Mathematics from BITS in India. He also has an MS in Computer Science from Clemson University in South Carolina, and he's been working in the telecommunications industry and networking field, contributing to data communications and wireless communication protocols as a system engineer for over 25 years, starting with 2G and 3G, and currently focusing on 4G and 5G designs, bringing many modem solutions to the market that are developed or deployed in numerous mobile devices and network solutions around the world. He has worked with ICL, UK, NASA, GSFC, Ericsson, and Qualcomm, prior to Qualcomm. Srini has over 100 issued patents and over 200 pending patents. He is the author of the Wi-Fi Interwork chapter of the book Emerging Technologies and Wireless LAN. He has co-authored key industry papers in VTC. He is also an active contributor to the 3GPP standardization process. Welcome, Srini, and thank you for being our speaker today.
Thank you for the introduction, Kevin. Hope everybody can hear me properly now. Good morning, everyone. I think the landscape of the deployed services for voice and SMS services are pretty long, and they have gone through a long history from 2G onwards. But it's still worthwhile with a multi-mode device with LTE, 2G, 3G, and Wi-Fi involved. Good to go through the full landscape of what is involved in these voice services and the different complexities and the variants which are in existence in the market. So this slide deck essentially, or this presentation, is focused towards bringing that into focus, showing all the different variants which are out in the market. And from that point onwards, trying to actually identify which is the best method and how to optimize the different solutions going forward to make the usability for a given user better as the different services, including voice and SMS, and accounting for the best effort traffic-based services which are there. So without much ado, I'll start going into the slide deck. And let me start with an overview. The overview is essentially saying that 2G, 3G, and 4G and Wi-Fi technologies are built into the devices now. And each of these technologies have a different way of supporting voice and SMS. Quite honestly, we had to reverse engineer and we had to re-engineer quite a bit of the work which was done on even a circuit switch kind of network and moving it into a packet switch network. And even between going from a 2G system to a 3G system, the amount of effort involved to enable voice and SMS-based services are very different, accounting for the different coverages and different bands involved. And the different variants of SMS and the different codec types and the variants of the voice which are supported in the different technologies. Everything poses a very different type of challenge, and we have to solve those individual problems on a technology by technology basis. And when you're going from within a home country operation or roaming within the country, including the MVNO support, interoperability with the other operators. Even now, we have issues with interoperability with operators in terms of the calling of voice and making basic voice service work. Global roaming, another big ticket item, accounting for costs for the different users involved, are key considerations that influence the technology choice. Legacy in terms of how the SMS itself is deployed and how the SMSC works, how authentication works, and how a given service is enabled in the market becomes very important in terms of managing future services without breaking legacy operations and legacy considerations. With these aspects in mind, focusing on the best choice for voice and SMS, noting the fact that you have different camping scenarios across the markets, different technologies involved. We need to account for mobility and maintain in-call service, transition across racks, and go across operator boundaries, maintaining continuity of service both mid-call and without loss of pageability. Both idle service and connected mode service becomes very relevant, and to maintain a greater service that needs to be achieved. That is key, and in fact, one of the key metrics which the operators always manage in the network, and the infra vendors are constantly bugged about maintaining that level of high degree of performance in the network. It doesn't matter which system that we are talking about. Voice calling and SMS-based services becomes very important. In that regard, presentation addresses the variance, the relevant market solutions, and the key aspects that will need to be addressed for a seamless operation. The multimode device configuration, together with 1x.tt, is used to describe the different behaviors and camping styles required to include basically a single mode camping, hybrid camping, and dual radio solutions. By single mode, that means you're only camped on one rack at a time. Hybrid, by that you're camping on something like an LTE system and monitoring a 1x system for incoming pages, while data is operating on LTE, voice calls are operating on a 1x system. And true dual radio solutions like SVLT solutions, which have full camping on both LTE and 1x type of solutions. So with all that into picture there, we really need to not just focus only on technology, but focus on a real day of use, which really is not very well defined as far as in the market in terms of performance verification. People look at it from many degrees to see whether the pageability is working, voice call is working or not, but is a given user really happy with the type of service that we are trying to provide? What is he typically trying to do in a day, and how are you working to make sure that the network coverage and the fact that the typical usage for that particular user is being optimized for different services that he's trying to do? You do know that you have, by machine learning, by other several techniques, the services he's trying to typically use. Daily routes are known, long dwell cells are known. That means you are in your home environment for 8 to 10 hours, office environment for 8 to 10 hours, and you're driving between a mall and a school or some kind of a shopping complex and home, and between home and office. So basically, long dwell cells and operation based on long dwell cells becomes very relevant. Conjoined operation with Wi-Fi becomes very relevant, and because Wi-Fi is there and present in full form, and we need to be able to capitalize on the usage of the Wi-Fi together with the operation with the cellular services. Potential full offload of services with small cells and Wi-Fi. Although Wi-Fi is there, Wi-Fi can become detrimental depending upon jumping between 5 gigahertz and 2.4, and it is really, the reliability of Wi-Fi can be questioned, and the backhaul can be questioned, but operating with small cells and making that work together with Wi-Fi can become a very strong potential solution, apart from augmenting with the macro kind of network out there. So with that in mind, I just jump into the different variants which are there for SMS. For SMS, you have 3GPP and 3GPP2 formatted of SMS messages. From a device capability, we are able to receive and process both formats. It doesn't matter what the format, in which technology that format of information of SMS is received. So we are quite comfortable receiving both formats on the device side. On the sending side, we actually have a very optimized way of looking at it, in the sense that we can optimize it knowing that the far end is a 3GPP type of device and use a 3GPP format. We can even use 3GPP transport paths, something like, if you're using S102, we do know that it is being received by the 1X MSC, and we do know the SMSC sitting out there is a 3GPP2 formatted SMSC, and we need to send it in a 3GPP2 format. Or as opposed to an LTE NAS-based SMS that you're talking, then we could potentially use a 3GPP format to communicate. So it can be contact-based, it could be transport path-based, and initially there was, even now as we speak right now, the operators enforce on selecting a specific method or a format of an SMS for the different technologies and different, when you're camped on 1X, you have to use 3GPP2. And when you're reformatting and sending and reply to that, it could potentially be when you're operating on LTE, send it in a 3GPP2 first, failing which, send it in a 3GPP format. And there are failure fallback methods also identified in these. So the transport paths for SMS. So the formats are 3GPP, PP2. Now looking at the transport, you have CS-based SMS, circuit switch-based SMS. You have packet switch-based SMS on 3G is quite prevalent right now, even with DO and HSPA. With dual camped on 1xRTT through S102, that means you're going through the S102 tunneling from the LTE system into the LTE NAS system, going into the MME, talking to the S102 side hall interface, going into the 1x BSC, and going into the MSC through that to the MSC there, to the SMSC server there. So this path of communication can still be 3GPP2 formatted SMS, and this is a transport which is there. LTE with 3GPP attached, combined attached, can have two methods of doing it. When you are camped on LTE with a 3GPP combined attached method, where you have SDS-based method or LTE NAS-based method, depending upon how the network is architected. Both these methods are a single method from a device perspective. The mechanism is combined and the device doesn't see the difference, but there are differences from a network configuration in terms of how they handle. And of course, the more prevalent form, which is coming, IMS-based SMS, which is there, which is a packet switch-based method. All of these other methods are actually circuit switch-based method of communication there. So SMS options itself, what is it used for? It is used for triggering data collection. It's used for triggering device configuration. And of course, you have the user MO and MT text messages. These MT-based triggers become very, very important because when a device is not behaving very well in the market, it becomes very important for the operator to quickly page those devices, get them into a configuration mode where they are shut down or done, things like that. It becomes, these MT pages are very critical and seen as very important for the user, for the operator to manage the devices in the network. MO and MT text messages are regular use of communication messages which are there. These are typical uses, and of course, we are actively competing with OTT over-the-top options which are there, WhatsApp and Twitter and RCS-based services, which is an IMS-based RCS services which are out there. So with that, I jump into voice options and call out what are the voice variants which are out there. You have circuit switch voice supported on 1xRTT, UMTS, GSM, CSFB that you're falling back from an LTE system into a 1x system or a UMTS GSM system for voice calling, and of course the hybrid solution. And I didn't call out the LTE solution because it's rather going out of fad in the market and nobody is deploying an SVLTE solution right now. SVLTE meaning that the device is full camped on both LTE system and a 1x type of system. So the hybrid solution is becoming a more de facto operation when VoLTE as a service is not available. By hybrid solution, I mean the device is camped on an LTE system and it is tuning away a receiver to go receive 1x pages, and it's walking away to the 1x system to place an MO call as needed. And now the technology variants for CS voice is covered. We talk about the VoIP and video telephony type of services which are there, which is VoLTE voice over LTE, and you have the voice over Wi-Fi, both of which are IMS-based services. VoRA, as in the voice over DO Rev A, is really non-existent in the market. Voice over HSPA becomes useful under one quantity and one quantity only, where the operators are deployed. Operators have actually taken a video telephony service and they have actually applied it to the fact that when LTE to HSPA handover is available, the device actually maintains the connectivity on a HSPA system more as a best effort kind of a calling without any QoS, but the video telephony is not broken, in which case it still uses a voice over HSPA without QoS, treating it like an over-the-top kind of application, but it still allows for taking a VoLTE type of call or a video telephony type of VoLTE call and taking it into a voice over HSPA. Now, voice VoLTE to HSPA never is only there in the sense that it will always use an IRAT mobility solution, which is an SRVCC solution going from a VoLTE system into a 3G system. I talk about that after I introduce the codecs. The codecs itself, you have EVRC, which is more of a 3GPP2 codec. The variants of A, B, and forms are there, and enhancing it to take it into a slightly wide band without network impact as far as the EVRC is concerned is already being planned and supported. AMR narrowband is supported, and AMR wideband is more prevalent right now on an LTE VoLTE system, and EVS is becoming commonplace with actually quite a bunch of markets already supporting EVS right now, major markets enabling EVS as we speak right now. EVS has two modes of operation, which is primary. Primary is pure EVS-based operation. AMR IO mode is interworking of AMR wideband on the far end and AMR IO mode. Let's assume you initially started the call with EVS, primary on the both ends. The far end went through SRVCC. It went from an LTE system to an UMTS system. So the EVS call got converted into an AMR wideband call, but the network allows the device to remain, this end UE to remain on EVS and move the mode of operation to AMR IO mode of operation, where interworking between AMR wideband and EVS mode of operation is maintained. And this allows for a slightly better degree of operation without any transcoding available requirement on the network side, while retaining the EVS-based service on the LTE system. So now, voice option has, of course, you have to manage mobility. Mobility has got IRAT mobility, where IRAT mobility is talking about PS-to-PS handover. PS-to-PS handover is LTE to LTE style of handover, or LTE to Wi-Fi style of handover, both of which are packet switch-based handover. Of course, LTE to Wi-Fi means that you're going through an EPDG solution in the network. And of course, the other IRAT requirement is going from a PS to a circuit switch call, where the handover to SRVCC is supported in the market. DRVCC is not enabled because no operator has actually required that kind of a requirement there. DRVCC can be useful under one scenario where you're sitting on a Wi-Fi system and you're walking out and there is no LTE system to hand off to, but there is a circuit switch system available for you. In that scenario, DRVCC can be effective in actually handing over and maintaining continuity on the call, going from a Wi-Fi, voice over Wi-Fi calling onto a circuit switch CS call by using DRVCC. But this has really not been requested by any of the operators right now. And of course, mobility, one of the things which we need to look out for is VoLTE and the fact that it's fully covered or not, and are there issues with VoLTE in the market, and how do you manage the issues in the market in terms of knowing specific areas where VoLTE can potentially fail on the device, where the device can autonomously actually switch to, even though it is an LTE footprint, it can switch between VoLTE to a hybrid mode of operation where the device is in the LTE camp on the edge of cell coverage. Well, it knows that at that point in time, it is not able to support a VoLTE call very effectively, and the call drops are pretty heavy in that situation there. The device automatically switches to an SR-LTE mode, and it's able to use that as transition points in an effective way to do VoLTE camping the most effective way possible, while switching to SR-LTE when required to support the call. TRFO, transcoder-free operation, of course, is ideal for interworking. It cannot be avoided in specific scenarios, particularly when you're going for an EVRC1X call into an AMR calling AT&T network or any other 3GPP codec which you're talking about. Transcoding will be required to be supported in those scenarios. So with that, I've introduced what is the different landscape involved as far as SMS options are concerned, the voice options are concerned, and what different technologies and what variants are available, including IRAT mobility features, which we need to enable to support voice going across different systems. Let me just dwell right now on the current industry trends which are involved there. LTE is sufficiently well deployed across the world. Across the board, you will see every country, there is either plans to deploy it or they are fully deployed as far as the country is concerned. They're covering more and more with LTE. Interworking with Wi-Fi has become a commonplace as well, in the sense that even calling when you're going home and where with heavy apartment buildings and things, coverage with Wi-Fi and using the Wi-Fi effectively to augment the LTE system has become commonplace right now. CSFP and SR-LTE hybrid solutions of voice are in place, fully deployed, both for 3GPP and for PP2. And IP-based SMS has become prevalent, even for operators that have circuit switch-based SMS that they support, but most of the effort is actually going towards enhancing IP-based SMS, and newer formats and newer methods of handling IP-based SMS has become more prevalent right now. They are slowly phasing off and going with EMSE and other optimizations to get to an IP-based SMS at any given point in time. ICS, when required, will also be supported, IMS centralized services, so that circuit switch, voice, and packet switch, IMS, SMS-based supports are all integrated into one core network, which is an IMS core network. SRVCC to 3GPP enabled. 3GPP to SRVCC did not get market traction very much. So it's currently broken across, going from an LTE system into a 1X system with continuity is currently not enabled in the market. VoLTE in a home is enabled in most locations where LTE is supported. Wherever LTE is deployed, except for very few scenarios, VoLTE is enabled along with LTE. Global roaming is becoming enabled with LTE. It's slowly starting to see. We are seeing LTE being enabled going within US and Europe, Europe and China, Europe and India and things, and US and Japan and companies. So essentially, voice roaming is only currently through CSFB method of operation. VoLTE-based roaming is still just about beginning. There's a lot of skepticism around essentially being able to enable it with authentication with this one, and VoLTE mechanisms working with QoS end-to-end with the PCRF node. A lot of interworking activities which need to be executed for VoLTE to be enabled across the markets. And different operators have different types of VoLTE requirements, and inbound roaming still requires some degree of work to make that in a very seamless way to happen. But it is happening, and operators are consolidating to a large extent to get to a single VoLTE requirement set. They are able to all camp across each other. VoLTE over best effort, this is a very interesting thing in the sense that some operators actually ask us to say that, can you make VoLTE work without QoS, without the visited operator knowing that you're placing a VoLTE call, but you're treating it as a best effort calling service, and you're placing the call over the internet PDN when you're roaming. This is to avoid voice roaming charges and allow for best effort voice to be supported, and yet home routing and allow the flexibility of operation. This can be very well seen as no different than operating on a Wi-Fi system, but they're asking for internet-based connectivity with VoLTE there. Voice over Wi-Fi based roaming is enabled. EPDG is home routed. We'll talk about this a little later also. EPDG based roaming, EPDG is the gateway connectivity between the UE and the internet, public internet, going into the gateway or a firewall, entering the operator network into the PDN gateway. And we were Wi-Fi based roaming using EPDG, which is EPDG actually deployed in the home network of the operator, is actually how it is getting enabled right now. EBS, as a codec, has started deployments in several markets already, like I explained before. Small cells, I'll talk a little more detail about the neutral host networks. It's starting to see traction because there's a lot of indoor penetration which is still pending out there. Small cell as a solution for different LTE markets with a macro, where they were planning on putting 16 small cells within a massive micro cell which was there. It's really not taking a whole lot of traction because of the ABS separations and a bunch of other LTE level issues that needed to be accounted for. There is traction for that, but it's not as prevalent. But indoor penetration becomes very important, and having each operator having to deploy a particular cell within the network, within an indoor platform, does not make a whole lot of sense either. And that's where hopefully the neutral host network will make it more prevalent and make it easy for operators to handle indoor penetration issues. It's handled currently. The plan is to handle it, enable NHN as a neutral host networks, is together with the VoLTE offload itself. So with that, let me segue into talking specifically about neutral hosts. What it is it's just showing the number of buildings which are there, commercial buildings which are there typically in the US setting that we are looking at. It's pretty lot, and to get to indoor penetration and 100% penetration in all of these scenarios becomes very hard to do. And in that, a neutral host, by neutral is it's operator neutral. Essentially, it's trying to say that, can we have a deployment in such a way that it is actually handling it using a neutral where any operator from a given country is able to camp on that network and capitalize on the availability of the service while they have some kind of an agreement, service level agreement across the operators with this neutral host operator. And it is also intended to be supported in a hotel, in a commercial stadium, in conferences and things like that. So with that, I just segue into showing a basic architecture, showing where there is a regular macro network, where you're going through a neutral host gateway, and home eNode B management server, and it's talking about different types of neutral hosts, where it could be fairly sophisticated, including additional local services being provided, or a very simple small business or a home kind of a hotspot where you put an outdoor in a house or do things like that. So there are several variants of these, including going to Crompton Inn or Best Buy or someplace where you're able to camp indoor on a neutral host, and you get this type of service through a neutral host gateway working through the macro operator and allowing the service to be enabled. I jump into the next topic, which is talking about the codec itself, which I said EVS as a new concept and getting traction in the market. EVS as a concept has narrowband, wideband, super wideband, and full band operation. And the codec itself has different rates with which it's supported. Currently, what is planned is narrowband, wideband, and super wideband. Operators are actually deploying all these three options right now, and going from rates up to 5.9, 6.6 kilobits per second, all the way to 24.4 kilobits per second. So as you can see how the significance of narrowband and the wideband and the super wideband, and the significance of each of these become in such a way that how fast are you sampling the audio? That's essentially what it's talking about. So EVS as a mechanism provides for channel-aware mode. I'll talk a little more about what channel-aware modes in the next slide. Designed for VoLTE and packet switch networks, where it is more error-prone and it is error-resilient using this method. Codec designed and tested under delay jitter conditions. It allows for better capacity. It's a super wideband at 13.2 kilobits per second. It actually goes to 9.9, but the 13.2 super wideband codec at this rate is recommended. Wideband starting at 5.9 kilobits per second. And it's got extremely good quality. It goes beyond what AMR wideband achieves. And it's able to at least get 0.2, 0.3 improvement in terms of the performance under lab scenarios that you're looking for, clean channels, specific settings that you're looking at. It has the ability to carry music with super wideband. And with that, I just want to explain what the redundancy and essentially the efficiency of the EVS codec itself. What it does is essentially it takes a frame n and it repeats the packets of n and n+1 in subsequent frames. And what happens is you transmit frame n, the repeated copy with redundancy frame offset of 2 is populated in this frame and it's transmitted out. So which implies even if this packet is lost, if the receiver receives this packet, it is able to take this redundant copy and recover most of what is needed for playing out that particular packet. And of course, the smart tricks required for the digital buffer management. When you're trying to play out this packet which is not there, you should be able to look ahead and pick up that packet when it arrives and play that out. So that is the level of redundancy that you're seeing in there. So now with that, I go into the LTE RAN enhancements and the 3GPP release 14 based features that we are studying right now. This becomes very relevant for all 1X operators right now because they're trying to get LTE to operate with the same parity as 1X footprint. So one of the key things which is also coming up is LTE over an eMTC device. First phase of that is the release 13 is a 1.4 megahertz narrowband LTE with coverage extension mode A. We have shown that we can actually complete the link budget even on a cell edge kind of a scenario with 32 repetitions on the channel, and we are able to take a variable voice with a single receive antenna, and we are able to complete the particular link on the channel with LTE there for eMTC. Now that is accountable for LTE, but a lot of the requests which we get are to not satisfy only LTE for a variable. You also need to have audio streaming. People tend to listen to music. People tend to listen to talk radios and things while they're running. So to allow for it to be enabled in a more seamless manner, the standard is talking about a 5 megahertz addition in the release 14, which supports both LTE plus audio streaming for an eMTC style device, which is a CAT-M device which you're looking at. Now, eLTE improvements are also being planned because this becomes very key to get the coverage extension and 1X coverage parity. So this is allowed for both Mode A and Mode B operations. It enables better coverage with LTE, and this is a release 14 work item. We are trying to see that if you're able to extend the VoLTE operations beyond just the TTI bundling that we're talking about, which is available in the of release 9, release 10, which was introduced in the standards, this is taking well beyond that, and it's trying to say that, can we get 1x parity with VoLTE enhancements, and it's being studied in release 14. Along with that, there are other study items which are there. It's making the eNodeB scheduling algorithm better by making the delay budget awareness. And when the UE is able to give the delay budget information, they're able to do that flexibly in terms of adding more repetitions to allow the link budget to be completed and manage the scheduling algorithm a little better. The second aspect of it is, again, knowing the delay performance on the device in terms of end-to-end calling. It is able to change the CDRX operation, something like if the delay is going beyond 280 milliseconds bounds, which are there for end-to-end voice packet, it is able to shut off CDRX. And it's able to either do 0 milliseconds or completely turn off CDRX or do 20 milliseconds CDRX instead of 40. We can sometimes even go to 60 when the delay performance is really good. And this variability of CDRX, managing end-to-end delay together with the UE input to the eNodeB, is becoming a topic of study, and it is happening in release 14. Another important thing is codec awareness, where it is able to know that it's an EVS codec, and it can move the SRVC threshold much later than what it should have done with an AMR wideband, because there is redundancy for EVS like I talked about. The packet loss can be extended even further. Instead of using a 1% packet loss, we can sustain even a 3–4% packet loss, and the channel will still sound good for an EVS type of codec. Of course, it's trying to manage the PER on the channel and the delay on the channel using the codec awareness, but the key aspect of it is the SRVCC handover threshold management based on the codec itself. So now, we need to do IRAT mobility. One of the key IRAT mobilities, like I talked about, is the SRVCC going into a circuit switch network. But also going between VO Wi-Fi and VoLTE becomes very relevant, and there are quite a lot of combinations to take into account. One is the preference itself, where the operator tends to have cellular preferred versus Wi-Fi preferred, where as long as cellular is available, don't camp on Wi-Fi, but there are many operators that choose to camp on Wi-Fi, but these preference order will change whether you're in home or in roaming scenarios. Available macro systems, when you're walking out of the Wi-Fi access point, only CS is available. There's not much we can do but drop the call or retain the call on the Wi-Fi system. PS-based mobility is supported, and if LTE handover can be handled efficiently, that's how it will be done. Mobility type can be idle or connected, because pageability as a service is as important as connected mode operation in terms of voice performance. Handover decision, it not only takes the source system's media metrics and RF metrics into consideration, it also takes the target system RF metrics into consideration in making a decision of when to hand out of the particular system. And of course, you need to build some degree of hysteresis so that you don't ping pong between the two. And some of the hysteresis and operations comes along with history-based information of learning what the device is capable of doing and what it has experienced on an access point before, and knowing what type of access point it is, which is a user-preferred system versus a generic AP and integrated with a small cell like an LTE plus a Wi-Fi system, which is coming up, LAAs and multifiers and different other forms of integrated small cells which are coming up. So knowing the type of Wi-Fi, when to exit that particular Wi-Fi systems becomes relevant. For user-preferred, you would know without having to do congestion recognition ahead of time whether it's performing well or not and how well it has performed for you based on the past experience. For a generic AP, the congestion changes quite a bit based on the number of users on that system, and managing this system takes slightly different performance metric analysis compared to handling a user-preferred system. An integrated cell, of course, together with an LTE cell of operation plus Wi-Fi, the behavior becomes very different in terms of handling that. So with that, I just want to talk briefly about roaming within the home country. Coverage and service availability, the focus should be on voice, SMS versus data. How are you going to stress on which one and which systems? And to be clear, voice-based camping and SMS-based camping can be different, and data-based camping, best effort database camping can be different. And based on the active service at a given point in time, we may choose a different system to camp on how to manage that. Navigation currently requires data can be managed with downloaded maps and standalone GPS. It's not very common right now. So, but you still need data to do navigation applications and things. Even if you don't do it for anything else while traveling, we still need to address GPS-based services to be definitely working at that point in time. I mean, cost-based camping is very important, being extremely conscious of cost-based camping. And currently, we have a rigid system priority provided in our camping algorithms by every operator. There's a PRL database, there's the MMSS tables, there's a PLMN tables, that's a technology order table, band class support table, different tables. All these tables have rigid mechanisms of identifying what is the priority, what is the technology priority, what is the system priority when you're going from one location to another based on different countries. All of this doesn't take cost basis into consideration, although the order in which they are listed are implicitly based on costs of the service that they're going to experience, because a lower preferred system will be less costly, more costly. So it doesn't take into account very much into the currently active services, because they may be, you need to camp on a different system based on the active service. And we are doing it in part, something like EMBMS or broadcast services available on a system. Then we go to that system accounting for that activity of monitoring and moving it to that system where it is able to operate, even though it is a higher cost system or a different PLMN and not the most preferred PLMN in that particular system. Restrictions on the allowed services are applicable because operators may say, when you're roaming, don't enable data. Or the user may actually say that, sorry. The user may actually say, when I'm roaming, don't enable data. Enable only voice and SMS, or they may even block SMS at that point in time. There are times when operators are enabling specific services on roaming systems, and we may leverage that kind of a service even if a home operator has not deployed VoLTE. When roaming, VoLTE service is available, they capitalize on that by allowing users to enable VoLTE there. So it can go both ways, where they enable or restrict services when they're roaming. And you're going into global roaming, it's a different problem. Data roaming is enabled, fine. Circuit switch, this global roaming is not going to be very common unless you're a frequent traveler. Even for a frequent traveler, they're going to be home quite a lot more than they're going to be globally roaming. Data roaming is enabled right now. When you're voice roaming is currently only supported using CS-based voice roaming. OLT-based roaming is beginning to happen. Even there, we are seeing, like I described before, voice over best shepherd is being requested to minimize the roaming cost there. IMS-based services, that is without QoS, that's what I meant here. IMS-based services will always be home routed because your registration is with the serving CSCF. It is always home routed. With EPDG-based connectivity for IMS-based services, which is what is going to become the de facto with the EPDG in the home network when they're going with the Wi-Fi-based services when you're roaming globally. And Wi-Fi-based global roaming is becoming commonplace, actually much more early than even VoIP-based roaming. They are enabling Wi-Fi-based camping using IMS-based services. With this, there's one key aspect of it which standards is still trying to figure out exactly how to manage this. It's called lawful intercept and Kalea kind of thing there. If you're home routing an EPDG, when somebody from, I don't know, India is traveling here and the EPDG is going into the Reliance network in India, now the US government is unable to do lawful intercept on that because all the voice packets are home routed going directly to the EPDG in the home of India operator network there. So addressing lawful intercept is now very clear how well it will work with EPDG-based home EPDG-based roaming with the global roaming across using Wi-Fi system. So this is becoming a key point of discussion, and I think operators' view on this will be greatly appreciated in the 3GPP standards in terms of that, how to manage this and how to handle this lawful intercept behavior when roaming. RCS-based services is over the top. And operators are currently actually integrated RCS services actually not taking traction at all. There is some degree of traction for RCS combining with an IMS-based registration, where they're doing it with both single and dual registrations, where single registration for voice, SMS, video, together with RCS-based registration, it is actually opening up a pipe from the core IMS stack, allowing the HLOS application to actually register with a single registration context by changing the set of feature tags, including the set of feature tags which are supported together with RCS. But the more common prevalent solution which is happening right now is operators are releasing their own version for download, and this RCS is actually standing independent of the IMS stack, which is being deployed with the modem solution integrated with OLT-VT kind of a stack, and it is operating over the internet PDN rather than over the IMS PDN. There are, however, operators which are deploying it on the IMS PDN with dual registration and with single registration, although the more common place is going to be the operator releasing their own version of the downloaded stack, and there are operators which work together with different companies which are releasing the RCS stack and making that in a downloadable form. So like I said, it is supported over either the Internet APN or the IMS APN, and the RCS version in the market is essentially Blackbird, which is the earlier version of 5.1, 5.2, and then 5.3 is the Crane version, which is there. Essentially different features being introduced, OMA Simple versus OMA POP, and different formats of the different file transfer methods and the different ways of discovering people and other things are identified in Blackbird versus Crane there. So you can actually go to the RCS website and get all that information. If you need specific information on that, please let me know. RCS of fundamentally, you have key set of enablers. There could be many services developed on top of it, but what you're looking for is how to find each other. So UCE with presence-based options, you're looking for presence versus options, and then you're using the server-based method, or you're checking directly with the foreign contact information using SIP options. First of all, you need to know whether you can, what you can do with the foreign, and you want to recognize that they are active and online at the given point in time. That's what UCE is used for. XTM and XCAP, it's currently not being used by any operator right now. Auto configuration is very important, and I think they are trying to, similar to the SMS-based MT paging and going through BIP as a better independent protocol to configure the SIM card and other things, there is device-based configuration which can be done quite a bit using HTTP-based methods and things, where auto configuration using RCS-based services is becoming useful and relevant. Similar to the OMA DM kind of operation, they're trying to use auto configuration to solve similar problems there. North American operator in China and India, OMA CPM is used. IM, short message, long message, session, and group chats are enabled through this mechanism here. Europe is using only OMA Simple right now. And file transfer and image share are also fundamental service enablers which are currently supported for RCS. But there are many prevalent other services based off of these fundamental key enablers and supported in the market right now. So some of the RCS vendors have come up with very sophisticated applications to handle many types of services on that. It would be good to look into those and see how well the market is catching on that. But there is heavy competition around this together with the other OTT apps like WhatsApp and other types of mechanisms of sharing similar information. But just that RCS brings into fruition, it works across operators, across applications, and it is able to actually very efficiently do that, and it retains the services as an operator-based service to do this functionality. And in that regard, RCS being enabled in the market is very useful for the industry as a cellular industry to make it happen. Like I said, all this is fine, SMS, voice, IRAD mobility, different technologies, all of the methods are available. Now the point is, how do you optimize and what is the typical type of optimization without blindly looking at hotspots, say, oh, I have call drops here, I have call drops there, I have these packet losses on this particular channel here. Looking at it in a more cohesive way, trying to look at it from a typical route of different users, understanding the roaming transitions, understanding service continuity requirements and the breaks in service, what is the user trying to do through the day, typical usage, both in-home, roaming within the country, and roaming outside of the country, what is the typical type of usage the person is trying to do, the percentage of time spent on Wi-Fi versus macrocellular network. And of course, like I described, small cells with LWA, LAA can be very effective going forward, because for indoor penetration, like neutral host network that I talked about, that becomes more commonplace. Together with multi-fire, all of this becomes slightly easily handled because LTE as a platform can handle all of those QoS and all of the barriers which don't need to be solved again with Wi-Fi. Wi-Fi comes with the best effort nature of it, percentage of time that you're spending on Wi-Fi and the types of services that you're offloading on Wi-Fi become very relevant. Effective augmentation based on above information and catering to service plans to match the user's needs can go a long way in making them happy, and essentially being very extremely conscious of all of these aspects and trying to define what is the type of typical day of use for a given user for that operator, and try to analyze that and try to find out what type of issues that user may be facing and managing those specific issues and making that person happy, or even teaching that person to use types of services and different locations, different positions, and helping the user understand the types of service that he's receiving from the operator goes a long way in making them happy. And with that, I conclude the presentation. Please let me know if there are questions.
Okay, we do have one question, Srini, and it is, would neutral home network be available to dynamic select VoLTE based or user preference?
Yes, it can be built that way. It can be operator driven in the sense that it's neutral host network. The host is neutral, not a home. But that aside, I think you're correct in the sense there are operators which are choosing to not offload VoLTE, but that requires more complex solutions to come into preview, by that it needs to monitor 2 LTE systems at a given point in time. That makes it somewhat detrimental in terms of operations, but if that becomes more commonplace and that is what is required, we need to look into it to see how to satisfy that request then. But for now, initial, very initial rollouts we are trying to target in 2018 timeframe probably is, I think looking into, or 2017, I don't know when it is basically, it is only offloading VoLTE into the neutral host network. For the simple reason, there are other tricks that can be played by paging the device on the neutral host network, and when a call comes, hand over the call to the macro LTE network, so that the device is still doing a single RX type of single receive communication there, and not having to monitor both the neutral host network and the macro network. But that again requires additional operator support to make it happen.
Okay, what are the impacts on SIM?
On the SIM card, there is additional credentials for neutral host camping that needs to be provisioned on the device in terms of access. The SIM card remains exactly the same, but they're talking about distributing certificates on the device to manage neutral host camping. But the user can still be authenticated through the home MME after the certificate is for camping on the neutral host, but the user can still be authenticated with his credentials with the home MME.
Okay. Next question we have is, does EBS code always run at 13.2 kilobits?
Okay, I can explain a little further on that. No, not necessarily. There is 2 aspects of it. One is channel aware mode, like I said, redundancy offset is supported, and you're carrying redundancy. But EBS can operate in anywhere from 5.9 all the way to 24.4 kilobits per second. Channel awareness, as we talk about it in the sense the redundancy copies are sent only in the 13.2 kilobits per second mode. That bitrate is the only bitrate that is allowed to carry channel awareness right now, or redundancy copies. Does it explain that in the sense that if you go out of the 13.2 mode of operation, and there is CMR change mode request can be sent to the device to change to any of the bit rates, and even in 13.2, you can be in a channel unaware mode or in a channel aware mode. In the channel aware mode, you are carrying redundancy copies. In any other bit rate, you can jump up and down, something like 24.4 without redundancy while operating on a channel. When the channel capacity is available, will outperform 13.2 operation with channel awareness. You will see a higher MOS performance. If you're able to jump into 24.4 and the channel is working very well, then it's really good. But if the channel has a PER, some degree of packet error going on the channel, there are losses on the channel, then operating with channel awareness in the 13.2 mode of operation is very useful to have.
Okay, so we have time for one last question. Can you summarize the major reason why VoLTE does not have the same coverage as 1X right now?
It is to do with the link budget associated with the VoLTE. And it is actually, in terms of the link budget numbers, need to walk through with this one. There are many presentations which have been made outside of this context here. It is actually 5 to 6 dB off in terms of the footprint based on how the LTE channel operation is happening due to the hybrid ARQ and the short time nature of the packet communication. In 1X, you're actually sending 20 millisecond packets, and you're doing soft handoff, and you're actually doing selection combining across the packets and making things happen. There are many ways. You have a whole 1.25 milliseconds, operation of packet. In the 20 millisecond packet is chunked into 16 of 1.25 millisecond packets, small packets, and each one of those are power control groups, and each of those power control groups, you can get redundancy copies across multiple channels, and you're able to combine them better. Here, you're operating on only one lick on the LTE channel, and you're also transmitting at a 1 millisecond TTI with hybrid ARQ. Hybrid ARQ does provide degree of redundancy, which helps bridge some of the gap, but the gap is actually 5 to 6 dB. We introduced something called as TTI bundling, where 4 redundant copies are sent with every HARC transmission. With every HARC transmission, it's able to actually, degree of repetition on that is able to bridge at least 2 to 3 dB on the channel. So we still have a 2 dB difference between what is happening from a 1X channel and an LTE channel of operation by the sheer physics of it. That's how the link curves are going to look like for you. Now the question is, like I described in TTI bundling, you're doing 4 repetitions to complete the link. Why stop at 4? Why not do 8? Why not do 16? And why not do 32? In fact, it allows even 64 repetitions on the standard right now. And if you're able to do 64 repetitions, you're able to go well into the cell edge in terms of coverage. But you got to note the fact that it is going beyond the 40 millisecond interval in terms of management of the packet. And you do need that repetition copy. HARC is not going to solve that particular problem. You do need redundant repetitions, back-to-back repetitions to complete the link. And the MCL that you compute to account for that particular operation is required to bridge the gap between 1X and LTE. By MCL, I meant maximum coupling loss, which is what I'm talking about.
All right, well, thank you. Looks like that's all the time we have questions for today. If we didn't answer your questions, we'll follow with you directly via email. Thank you again, Cerny, for speaking today, and thank you to all the attendees for joining us. We hope you found this webinar engaging and helpful. If you missed any portion of this webinar, the archive will be available in the next 24 to 48 hours on our website, which is mobilitydg.org, or on our YouTube channel. If you have any questions or come up with questions afterwards, please feel free to email us at info@mobilitydg.org, and we'll get those answers to you as soon as possible. Thanks again, everyone.
Thank you. Thanks, Kevin. Thanks, everyone.